Hello everyone, welcome to HashiTalk Secure. I hope you all are having a great day so far. So when we are talking about security, you all must have heard about the buzzword nowadays, which is zero trust security. This term basically signifies that you should trust nothing and authorize and authenticate everything. In our today's talk, we'll learn about how in the context of resources often residing in private networks and cloud environments, the integration of HashiCorp Boundary and HashiCorp Vault helps us in achieving the core fundamental of zero trust security. My name is Japneet Sahni. I'm a cloud and DevOps consultant at Arctic. I'm passionate about DevSecOps tech tools and technologies. I'm also a HashiCorp Boundary core contributor for this year. Now let's start with our talk. So the agenda for our today's talk is going to be something like below. We'll start with the traditional workflow for privilege access management. We'll see what are the different challenges with such a kind of a workflow. And then we'll see how Boundary Vault integration comes to the rescue. We'll try to understand a couple of use cases for accessing Windows and Linux servers as part of this PAM. And then we'll finally end this talk with a nice demo. Okay, so let's see what a traditional workflow for PAM looks like. Let's see, we have to access a private resource. It can be a database or a virtual machine. And these machines reside on private data center, on premises, or any private network of a cloud service provider. Now a user, let's take an example of a database administrator who wants to access the database in this private network. He is ideally not on the private network. They are either working in their office or they're working in their homes. Now, if this user has to connect themselves to the private network, first of all, the organization set up a VPN gateway or a bastion host. In case of VPN, they might get an IP address that puts them on the network, or in the case of bastion host, they need to get their SSH keys configured. Once we are inside this private network, we can literally access everything. So in practice, what we probably also do is have some form of firewall setup that's going to restrict traffic. So in our case, we are going to create a firewall that says, okay, traffic can go from a bastion host or from a VPN to this database residing in the private network. And finally, once the user connects all the way through the database, they also need a username and password to connect to it. So if we consider this workflow, you will notice that there's a bunch of information the user needed. Firstly, the user needed to have a VPN or SSH credentials. Secondly, they needed to know the IP or the host name to connect to. Then finally, they actually needed the database credentials to get all the way through to that system. Now let's see what are the challenges with such a kind of a workflow. The very first one being the onboarding and the offboarding of users. I don't want to distribute VPN credentials and SSH keys to everyone who joins the company or everyone who leaves the company. This would definitely become a burden, especially if we consider best practices like key rotation on a regular interval. Secondly, once the user has VPN access or access to Bastion host, she literally has a wider network access, thus increasing the attack surface. As seen in the last slide, we will try to bring in some firewalls in order to mitigate this issue. Now, this firewall setup is fine unless and until we have small number of static hosts where IPs aren't changing much, but this wouldn't scale when we have a highly dynamic infrastructure, especially that auto scales. Also, nowadays, we are moving to more ephemeral platforms like Kubernetes, where if a node dies, applications might be migrated to a different node. We're also adopting more serverless things where you really don't think about a host or a node or an IP anymore. It's really about this logical service that you're trying to route to. With all of these, we are really moving away from relatively static infrastructure to much more dynamic infrastructure. Lastly, if I have to expose database credentials directly to my user, what happens if those get exposed or compromised somehow? I don't want to have a static, long-lived credential that gets leaked. Someone might store it on their laptop, or they might put it on a Confluence doc, which might be exposed to internet, or they might paste it onto a Slack conversations or get saved into a log file somewhere. Ideally, why should I even give those credentials directly to an end user? So the question is, how do we move away from static credentials and instead create a credential on demand that that's short-lived and we can revoke it when we don't need it anymore? So there are a number of challenges in this workflow. And if we have to move towards zero trust security philosophy, wherein I really don't have to trust my private network, I definitely need to do something differently, right? And this is where HashiCorp Boundary and Vault integrations comes to our rescue. So now let's see how Boundary Vault integration will solve all these challenges which we discussed with the traditional workflow. Firstly, with the boundary, every user is going to log in through our identity provider. If your organization already uses Azure AD or Okta or any other IDP, the boundary administrator can configure the same IDP for authentication. Once authenticated using this IDP, you prove that you are a valid user. Now, when we talk about onboarding and offboarding of users, it is just about adding or removing those folks from the IDP. There's no additional step of distributing VPN or SSH credentials or rotation of SSH keys. Thus, we solve the authentication very easily with Boundary. Now, once the user has authenticated, there's going to be an authorization based on certain set of roles and permissions. So we are going to have a role, and that role is really going to drive our role-based access control. For example, in our case, our database administrators, they get access to databases and web developers get access to web tier. But we aren't going to specify this role for a single host or a single IP. It's actually going to be at the logical service because that's what we really care about now. This is really important because the logical service lets us elevate from the details that are dynamic. You can basically differentiate between these logical services in a cloud service provider using tags like Azure tags, AWS tags, GCP tags, right? Database can have a database tag and a web tier can have a web tag. So if database administrators have to connect to database, the set of databases can be dynamic, the IPs can come and go, they can change, they can be scaled up and down, but the overall control remains the same. So we have now solved the authentication and the authorization part. The user is authenticated and authorized to connect to certain set of host targets based on his roles. Now, once the user sees this host and clicks on connect, we'll see this in our upcoming demo. The boundary will directly establish a connection to the target system. One of the key advantages of this approach is that you will not be specifically bridging the client onto the private network. So we stay in the line with sort of a zero trust network philosophy where we are not bridging those users onto this private network. Finally, let's talk about those scary static credentials, right? This is where HashiCorp Vault comes into picture. HashiCorp Vaults is a secret management tool from HashiCorp, which is capable of generating dynamic and short-lived credentials through its different secret engines. These secret engines can generate dynamic credentials for any kind of database. It can generate, rotate LDAP passwords for Active Directory, or it can even generate OTPs for Linux machines. These credentials are tied up to TTL, or in some cases can be used only once. Boundary integrates seamlessly with Vault to broker the credential, which will then be used when the user connects to the target system using Boundary. So if we have to summarize all the previous slides, you will notice that Boundary users will authenticate to Boundary using an identity provider. Once authenticated, they will see only certain set of hosts or targets which they are authorized to see, courtesy roles and permissions. Finally, they make a proxy connection to the target system using Boundary and gets the dynamic credentials for the target system from HashiCorp Vault. These set of credentials will expire after certain TTL or can be configured to be used only once. Okay, so now let's see a couple of use cases for this privilege access management, right? So let's talk about the first use case. My first use case is about accessing some domain joined Windows servers using OpenLDAP secret engine, right? So now let's see what should the workflow for such a use case look like. So the boundary user will connect to the boundary desktop application. Once he's connected to the boundary desktop app, he's going to authenticate himself by the authentication method, which the boundary administrators might have configured. So in our case, let's take an example that the authentication method is Azure Active Directory. So once the boundary user is authenticated using the Azure Active Directory, the next thing what he's going to see is a set of hosts to which he is authorized to make a connection to, right? So user will select a particular host and he will click on the connect button. So as soon as he clicks on connect, right, what is going to happen is a request is going to be sent to HashiCorp Vault for generating or retrieving the uh, credentials for that particular user. So now what is happening in the background, right? So now this HashiCorp Vault, so what we have done is we have enabled OpenLDAP secret engine. And what does this secret engine do is this is tied to your Windows server's Active Directory. And this secret engine is capable of generating your or rotating your Active Directory passwords every n hours. It could be 5 minutes, it could be 1 hour, it could be 4 hours, or it could be 8 hours, right? So it is based on certain TTL. And this Windows Server Active Directory is in turn domain joined with your Windows servers, right? So now HashiCorp Vault is going to return back the AD password, and it is also going to send you a proxy URL. Using that URL, the boundary user is going to make a proxy connection to the Windows servers and provide the AD password, which is returned by HashiCorp Vault to that Windows servers, and he should be authenticated successfully. Okay, so this use case is for the Windows servers. Now let's try to understand the other use case, but this time it's for Linux users, right? So what if we have to access Linux servers with local accounts? And what we can make use of here is the SSH-OTP secret engine from HashiCorp Vault. So now let's see the workflow here. So same as before, the boundary user goes to boundary desktop app, he authenticates using the Azure Active Directory. Once authenticated, he sees selected host or which he is authorized to see, right? And once he clicks on that connect button, right, he is going to, so in the background, the request is going to go to the Vault, right? And Vault is going to give a OTP. It's going to generate an OTP for that user and that particular Linux machine. In using this OTP and the proxy URL, the user is going to present this OTP to that Linux machine, right? Now, there should be someone who has to authenticate the authenticity of this particular OTP, whether it's a valid or an invalid OTP, right? So for this, what is going to happen is there is an agent which is going to be configured on all of these Linux machines, which is a Vault SSH helper. And this agent is responsible for validating that OTP, which is presented by the user with the HashiCorp Vault. So if the OTP is valid, the user will be automatically be authenticated into that Linux machine. So now let's try to see these two use cases as part of our demo, right? So if you notice here, so this is HashiCorp Vault, right? In HashiCorp Vault, I have configured an SSH secret engine, and you can see all the SSH roles, OTP roles over here for every user. Similarly, I have an OpenLDAP secret engine for the Windows use case, right? So this is the HashiCorp Vault configuration. Now this is boundary, HashiCorp Boundary UI. Here you can see an organization where you organize all your projects and IAM resources. In the boundary project, you can see that I've configured Azure AD as my authentication method. In the user sections, you will see all the boundary users who have already authenticated to this boundary system. This is the roles where the authorization happens, right? So if I click on any of the roles, you will see that this principal test vault -user1 has certain amount of permissions, right? So this user can do those things. Now, if I go to an HashiCorp project, you will see that it organizes all the resources such as targets and host catalogs, right? So in the host catalogs, we'll talk about the static catalog first, right? So in the static catalog, right? So what you actually do is you configure all your host manually. So you basically create host sets, and host sets can have multiple Linux hosts. So if I go and click on a certain host, you will see that I've configured these hosts manually, right? So I've given an IP for this particular host. Now, if I go back to host catalogs, I'll see the other type of catalog is a dynamic catalog. So this is an Azure dynamic catalog. So if I click on this catalog, you will see that I don't have to configure host. All I have to do is just create an host sets, and all the host will be filtered based on certain tags, right? So the host will be automatically be dynamically populated. So credential store is something which is going to be responsible for generation of your credentials. So in our case, we are using HashiCorp Vault as a credential store, right? So if I go back to the credential libraries, I'll see that I have multiple user-specific credential libraries. So every Vault path is user-specific, right? So if I click on, and this is like a dynamic credential library. Here, this is not a user specific. Indeed, the information will be populated from the boundary user's account, right? So if I go back to the targets now, right? Targets is something which the users are going to use for initiating these sessions. So this target is made up of two things. One is the credential libraries, and the other thing is the host sets or the host which you configured in the last. So this is a user specific target, which is tied to a user specific credential library and a host. So now this is boundary desktop application where I have authenticated using Azure AD. So I can see all those targets which test vault-01 user has access to. So he has access to these three targets. First of all, I'm going to click on the Linux target for this host. I will see that I'm able to see three different types of host, Linux host for this user. So now if I have to connect to this Linux host 3, I'll click on the connect button. I'll see a couple of information here. First is the proxy URL, and the other thing is the OTP, which is generated from HashiCorp Vault. So what I'm actually going to do is copy this OTP and make a note of this proxy URL, because I'm going to use this port for making a proxy connection to that Linux machine. So I give my proxy port number, and I paste my OTP, which has been generated by HashiCorp Vault, and boom, I'm authenticated to my Linux host 3 machine, right? So now if I close this and I go back to sessions, I can see all the active sessions which has been initiated by this particular boundary user. So next, we'll go to the Windows target. Similarly, we'll see 3 Windows servers, right? I'll try to connect to one of the Windows servers. I'll click on connect. Again, I'll see a couple of information, the same proxy URL. And this time I'm going to see a password, the AD password for test vault-user1 user. So this is the AD password. I'm going to copy this password, take a note of the proxy URL. I'm going to change the proxy URL to the exact port, click on connect, and I'll present my AD password, which has been generated by Vault, and boom, I'm connected to my Windows servers, right? So this is how we connected to our 2 use cases for Windows and Linux servers, right? Now, if we see from the infrastructure side or the infrastructure as code side, right, all the configuration has been done using Terraform. So Windows, OpenLDAP, secret engines, configuration of those secret engines within Vault, right? Creating all those OpenLDAP secret roles for every AD user, right? And similarly, enabling of the Linux SSH-OTP secret engine, and then similarly creating roles for every Linux role or every OTP role, right? Similarly, at the boundary side, all the organization, projects, authentication method, everything has been done using Terraform, right? This is where your boundary vault integration happens, right? Creation of the credential store uh, as a vault, creating all the static host for Windows. Um, and if we see here, we are creating all the roles, targets, everything using Terraform. Similarly, we are creating static host for Linux. If you see the target, right, we are using the port as 22 and 3389 for Windows, right? Similarly, what we are also trying to do is creating dynamic catalogs. These are Azure catalogs. As of now, Boundary only supports AWS and Azure as the provider. So we are creating the dynamic host, and this is where we are creating host sets based on certain tags within Azure, right? So yeah, this is from the demo perspective. So now I would like to take an opportunity here to highlight one of the challenges we faced during the implementation of the use cases I just demoed, right? So you would have noticed that during the demo, we created a lot of user-specific targets in Boundary. The challenge was that the credential library paths, which you see in the middle column of the before scenario, right? These are user-specific. And if you need to tie these credential library paths to targets, the outcome is a user specific target. And this is what resulted in resource sprawling for us. For example, if you have 1,000 users, this will result in 1,000 targets being created in Boundary. So we went back to HashiCorp and closely worked with the HashiCorp Boundary product management team to highlight this issue. And later in version 0.11.1, Boundary was released with a new feature of credential templating, which made our lives so easy. So as part of this feature, you will notice that the credential library paths can now be templated and can be populated with Boundary user or the account details. Thus, you no longer need to maintain targets for each user and can configure one target with one credential library for all the 1,000 users. So yeah, that sums up my talk for the today. Thank you very much for joining this talk. Have a great day. Thank you.